One wing break, two sharp angles, canards up front. On paper it looks like a compromise, until the Viggen moves and the geometry starts making sense.
Sweden didn't design for perfect weather. It designed for reality, and that reality shaped every aerodynamic decision. The Viggen's double delta isn't decoration. It's a speed and control bargain written in aluminum.
Put lift in front, and the airplane changes its attitude, literally and aerodynamically.
Close-coupled canards don't just add lift. They condition the airflow, feeding energy into the wing.
The inner delta carries the heavy work, lift at low speeds, stability, and space for structure. The outer delta changes the game, helping the aircraft stay efficient as speed rises.
Small angles up front can reshape the entire lift picture behind them.
Aerodynamics isn't just wings. The engine must breathe cleanly through every phase of flight.
A design built for short fields has to feel controllable on the ground too, especially when the surface is slick.
When runway length is limited, the first seconds matter, and the canards are already working. The geometry is doing its job, creating lift where it's needed, when it's needed, without wasting runway.
The inner wing wants control, the outer wing wants speed. Together, they make a balanced climb.
Those spirals aren't just pretty. Vortex lift keeps the wing effective at angles that would break other designs. The canard energizes the flow, the inner delta captures it, and the whole aircraft gains control margin. On a delta, the trailing edge does everything. Pitch and roll, in one coordinated language.
A unique planform only matters if it's predictable, especially close to the ground and in rough air.
Sweden's defense logic lived at low altitude, terrain, weather, and speed woven into the flight profile.
When runways are targets, you build alternatives, roads become airfields, and design must adapt.
This is where the canards pay rent, helping the jet stay controllable at slow speeds, without losing authority. Short field landing isn't gentle. It's controlled force, designed to stop quickly and safely. The Viggen wasn't just made to fly. It was made to recover on short strips and clear the lane fast.
Dispersed operations demand speed on the ground. Every minute counts. Every step has to be practiced.
A sharp planform needs strong structure. The kink is aerodynamic logic backed by engineering muscle.
The Viggen uses vortices on purpose, organized turbulence that turns into lift and stability.
The canards give the pilot a cleaner handle on pitch, more control without pushing into instability.
That broad inner delta isn't only aerodynamics, it provides room for systems that make dispersed operations practical.
The outer delta helps reduce drag in faster flight, letting the jet keep speed without wasting energy.
Good aerodynamics feel like confidence, stable sightlines, predictable response, and no surprises.
The story starts as geometry, angles chosen to balance lift, drag, and control across the envelope. Before flight tests, there's controlled airflow, where problems show up early and solutions get sharper.
Vortex lift is controlled chaos, high-energy airflow that keeps lift alive when speed drops.
Close-coupled canards help maintain control where air is messy, near terrain, in gusts, and in changing density.
A distinctive planform becomes unmistakable from above. The Viggen's wing is a signature written across the landscape. The secret is coordination, foreplane and wing working like a single system rather than separate parts. STOL thinking isn't only wings. Landing gear and structure have to absorb real-world surfaces.
Short strips force honest engineering. There's no room for fantasy numbers when trees start immediately.
The design supports the concept.
Land, service, and get airborne again before anyone can predict your location.
Most wings hide their logic. This one displays it openly, like a blueprint turned into a weapon-grade tool.
The Viggen's Canards and double delta wing weren't chosen to look futuristic. They were chosen because Sweden needed a jet that could.
Canards can keep the nose obedient at lower speeds, giving a pilot options where other jets start to feel edgy. The vortices help the wing stay effective, turning angle into lift without the sudden loss that pilots fear.
Variants changed, missions evolved, but the aerodynamic architecture stayed because it worked.
Even standing still, the planform speaks, built to generate lift, survive rough strips, and keep control under pressure.
The canard sets the tone for the airflow, like a conductor cueing an orchestra before the main melody.
The double delta brake is a design decision you can trace with your eyes. Inner wing for lift, outer wing for speed.
At speed, the outer delta helps keep the jet efficient and stable, geometry working silently.
The canards add authority when speed drops, helping the jet stay predictable instead of nervous.
Canards help trim and balance. The pilot spends less effort fighting pitch and more focusing on precision.
Nordic operations force discipline. Ice, snow, and salt can ruin aerodynamics if you get lazy. Aerodynamic concepts only work when systems support them. Controls, hydraulics, and reliability under field conditions. Canards and elevons are only as good as the power that moves them. Fast, precise, and dependable.
Short field capability isn't a slogan. It's a measured, repeated performance that crews trust.
The layout is deliberate, close enough to influence the wing, far enough to stay controllable across conditions.
The Viggen shifts personality without chaos, geometry and control laws guiding the transition from fast to slow. The real proof is repeatability. Short field capability that works again and again, not once.
A road base only works if you can land, stop, and move quickly, safely, and without bottlenecks.
The aerodynamic efficiency buys range, and range buys choices, especially when bases are dispersed.
A design succeeds when the pilot workload feels manageable, when the aircraft helps instead of argues.
Drag hides in small imperfections, so the Viggen's skin is part of its performance story.
Dense air near sea level changes everything. Lift increases, turbulence increases, and control must stay calm.
The inner delta becomes a lift reservoir, fed by canard vortices that keep it effective under stress. The outer delta helps manage drag as speed rises, so the aircraft isn't punished for being versatile.
On approach, pitch control is everything. Canards keep the nose honest and the touchdown repeatable.
Close-coupled canards demand trust, so the hardware gets inspected with obsessive precision. The double delta wing's strength lives here, structure designed to survive hard landings and rapid turnarounds.
You can identify a Viggen instantly, because its design is a solution, and solutions have a shape.
Different roles, same physics, because the core aerodynamic architecture was already optimized for Sweden's needs.
The Delta's control is all here, small motions that translate into stable flight and confident landings.
A thin layer of ice can erase lift, so cold weather discipline protects the design's advantages.
Power supports the wing, thrust to accelerate, control surfaces to shape lift, and canards to keep it all coherent.
When the runway is short, the canards become a promise. Lift now, control now, commit now. As speed increases, the wing's efficiency returns. Outer delta doing more of the work.
A successful configuration feels unified, one aircraft, not a collection of parts.
The Viggen's aerodynamics enabled the concept, but the concept was bigger. an entire mobile ecosystem.
The differences are clear. Most jets choose one delta. The Viggen chooses two and adds canards to make it all behave.
This aircraft lived in harsh conditions, and the airframe tells the story in small, honest details.
The configuration shines in the most unforgiving moment. Low speed, low altitude, limited runway, no room for error.
The wing and canards made the landing possible. The overall design makes the operation practical.
When the sortie ends, the aerodynamics stop being theory and become maintenance, inspection, and readiness again. Close coupling demands precision, spacing and shaping that guide airflow exactly where the wing wants it. One sharp break can rewrite performance, changing how the wing handles lift, drag, and stability across speeds. The silhouette remains iconic because it's honest, shape driven by a mission, not fashion. The Viggen proved the configuration could be more than experimental. It could be operational, rugged, and repeatable. At cruise, everything looks calm, but that calm is engineered, the result of a wing that knows how to be two things at once.
The Saab 37 Viggen is proof that aerodynamics can be strategic. Double delta wings for speed and